Everyone says the virtual DOM is faster, that it is the reason modern apps feel smooth. But here is the problem. That is not actually true. The virtual DOM does not make your app fast. In a lot of cases, it actually makes it slower. So why does everyone still believe it? And what is really happening inside the browser when your UI updates? Let's break it down. Here is the story you have probably heard. Updating the real DOM is slow, so frameworks use a virtual DOM, a lightweight copy. They compare the old version with the new one, then update only what changed. Efficient, right? It sounds clean. Logical? Almost too perfect. But this explanation leaves out something critical. The browser is already optimized to do this. The real DOM is not just a dumb tree of elements. It is part of a highly optimized rendering pipeline. The browser handles DOM construction, style calculation, layout, paint, and compositing. It batches operations. It defers work. It avoids unnecessary recalculations whenever possible. So when people say DOM updates are slow, what they really mean is poorly managed DOM updates are slow, not the DOM itself. If you slam the DOM with forced layouts, constant reflows, and synchronous reads, it will choke. But that is not a DOM problem. That is a developer problem. So what is the virtual DOM actually doing? It adds another layer. Instead of updating the DOM directly, you create a virtual tree in JavaScript. Then, on every state change, you recreate that tree, compare it to the previous version, run a diffing algorithm, and finally apply updates to the real DOM. That is more work, not less. You are trading direct DOM operations for memory allocation, object creation, tree diffing, and reconciliation logic. All of that runs in JavaScript before the browser even gets involved. So why does it sometimes feel faster? Because it standardizes updates. The real advantage of the virtual DOM is not raw performance, it is predictability. Instead of developers manually mutating the DOM in scattered and inconsistent ways, you describe the UI as a function of state. That constraint forces structure. It reduces accidental reflows. It prevents chaotic updates. It makes complex interfaces easier to reason about. So yes, apps often feel smoother, but not because the virtual DOM is inherently faster. It is because it enforces a cleaner model. But this is where things start to break down. The virtual DOM struggles with high-frequency updates, large component trees, and animation-heavy interfaces. Because now, you are rebuilding trees over and over. You are running diffing logic constantly. And that overhead adds up. At a certain scale, the abstraction becomes the bottleneck. This is why newer approaches are gaining traction. Systems built on fine-grained reactivity, direct DOM bindings, and compile time optimization skip the diffing step entirely. No virtual layer, no reconciliation, just precise, targeted updates. Instead of asking, what changed in the entire tree, they ask, what exact value changed, and update only that. That is a fundamentally different model. And quietly, the industry is shifting in that direction. Not all at once, not dramatically, but steadily. Because developers are starting to realize something important. You do not need a full tree diff to update a single piece of text on the screen. That is overkill. So here is the truth. The virtual DOM is not magic. It is a trade-off. It gave us structure. It gave us consistency. It made large applications manageable, but it also introduced overhead. And now we are starting to outgrow it. If you actually want fast applications, stop asking whether the virtual DOM or the real DOM is better. That is the wrong question. Start asking how much work you are forcing the system to do. Because performance is not about the tool, it is about the pipeline. Thanks for watching Front-End Systems Lab. Please subscribe if you want to see what is really happening under the hood.